Hi, everybody. Welcome. Just giving everyone some time to log in. Feel free to use the chat if you have any questions. Just get this set up. Hi, everybody. Again, welcome. We'll be starting in a few minutes. Just waiting for everyone to jump in. Feel free to use the chat if you have any questions. Hi guys, we're gonna be starting soon. Sorry. So again, if you guys are gonna be inappropriate, I'll be removing people who are being inappropriate in the chat. I had to check in that was Jesus.
Allow me to find you in the middle of the darkness. Night is true. I will rescue.
There we go. Sorry guys, make sure that you're on mute. I just went ahead and muted everybody. Make sure that you are on mute. All right, awesome. Everybody, welcome. I'm going to go ahead and begin our meeting. So right now, again, I'm just taking a look at who's attending. Make sure that you're using your real name so I could give you credit for attending. Let me go ahead and begin our meeting. And again, if you're accidentally unmuted, just mute yourself. That should be fixed. All right, so we're going to go ahead and be applying our big ideas in today's lesson. April 14th. Again, please be reminded that this session will be recorded. Again, it's important for those who don't have access to this to be able to watch this. Next up, active listening, one mic. Please be kind to each other in the chat as well. Please make sure you're kind, or kind of have to remove you if you're not kind to each other. Respect different opinions, participate. So yes, for credit, you want to participate. Make sure I know who you are, that you're using your real name, and be present. So I'm hoping, and I know it's not possible for everyone to have like a space where you could be focused and away from distractions and noise, you know, depending if you have siblings, things like that. So I'm hoping, try your best to be present though. Okay. Sorry guys, I'm just admitting a few more. All right. Use the chat to share ideas or ask questions. I see that you all know how to use the chat. All right, I see you guys. Okay, cool. If you want to provide feedback, you can use those little reaction buttons. Raise your hand if you really want to speak verbally, but about the content that we're discussing. And then turn off your mic if it's accidentally on. And again, try to refrain from multitasking. All right, so those are some of our norms. Let's jump into our agenda today. So we're gonna jump into a quick check-in question. We're gonna go over a little bit of some updates on our pre-calculus class now. We're gonna be looking at today's assignment that's gonna be due today at midnight. So those are the important topics that we're gonna cover in today's meeting. Again, I'm hoping it's gonna be useful to y'all. And again, feel free to use the chat to ask me questions. All right, let's see what you guys are chatting about. Okay. Anyway, connecting. The check-in question today, and again, this is based on participation. It's a very low-key kind of check-in question. What show are you right now watching on Netflix? Or any show. It doesn't have to be that you're watching it on Netflix. So right now, go ahead and in the chat box, answer what show are you guys watching, okay? Let's go on for a little bit, 30 more seconds here. Put in what you're watching. Give us some ideas, you know. I think I'm watching about like 3 shows at the moment. All right. Thank you for sharing what shows you're watching. I might be stealing from this list. All right. Let's go ahead and move on from this question. Awesome to make those connections. All right. So some important updates that I want to go over are pre-calculus live classes is now going to be every Tuesday at 12 noon. We will have 3 lessons or assignments per week. I don't know if y'all noticed that in the calendar, but now per week it's going to be 3 lessons or assignments, and that's including our live lesson. For example, this is how this week looks like. Notice how I gave you guys Monday, Tuesday, Wednesday. I didn't give any assignments for Thursday or for Friday. So you just have these 3 lessons for this week. I'm trying to kind of play around what 3 ideal days for the week that I've been liking. I kind of do like the Monday through Wednesday kind of thing, so that Thursday and Friday can leave you some time, some wiggle room there. Feel free to let me know what y'all think on that. Here's where we're at today. And we have a lesson that's due today. I'm going to be uploading today's Zoom video as well, the recording of it, but that upload is going to be by like 5 p.m. It does take a while to upload this. But if you click on there, it shows you all the instructions for how to do today's assignment. Okay. Cool. So again, if anyone has any questions about our live meeting in pre-calculus or this week, let me know. Okay, cool. I don't think we have any questions. Okay, so today's assignment looks like this. I went ahead and took a screenshot of it. We're gonna try, hopefully, to start this assignment today with some discussion. And also, by the way, I wanna remind you all to please use the link support that I have for you on the assignment. Also, take a look at the comments I make on the assignment to help you out. Lastly, a quick reminder, use your resources. They are there for a reason. For example, use any example screenshots I've been providing y'all, right? Any video supports I've been providing. And also, don't forget about the Juicy Big Ideas packet. I saw y'all making those really, really great comments yesterday, giving each other feedback. I was really excited by the conversations that I saw. Again, there's some juicy ideas here that you want to be using to apply them to the problems that we're going to be doing today. Okay, great. All right, y'all, ready for the lesson? We're gonna first think, then share in the chat, or if you want to raise your hand to share verbally, you're gonna follow these directions on the right side of this screen. Take a look at that as I go over the directions right now. So the directions are, we're gonna take a look at one math problem together. It's the one that's due today. We're gonna first off identify important information or quantities about the problem itself. Number 3 is we're going to come up with possible questions that I may ask you about the question itself. And number 4, we're going to start to dig into the problem and get started on the task that's due today. So those are the directions. Again, if you have any questions on those directions, feel free to put them in the chat. Okay, cool. So again, I'm just taking a look at our the chat just for relevant stuff. Okay. Okay, cool. Let's move on. By the way, though, if you want to use the chat feature, that's perfectly fine. In our last meeting, you all were participating using the chat feature. Now, let me say this. To participate and to receive credit today, I need to see on-task participation. That means it's okay if you guys are having a little bit of like, a bit of side chatter right now in the chat, right? As long as it's not disrespectful. But um, if you want credit for participation today, you want to make sure that when I ask those math questions that you are jumping in and participating. Let me know if anyone has any questions on that part. Okay. Sorry, let me admit one more. So David, you had a question. How are we supposed to be on task? On task right now is going to look like, right now I'm going to present to you a question. And you're going to try your best to participate either verbally or you could use the chat box right here. Let me know if you have further questions on that, but here were the directions on what we're going to be doing today, right here. This is what we're going to be doing, and the participation part comes from steps 2 to 4. That's how today's participation will look like. That's how on task will look like. But okay. All right, everybody, here is the problem. Let's first, and again, don't be afraid. Let's read it together. That's step 1. And just push this here. Read the problem first. So you could read it to yourself. I'm going to go ahead and read this out loud. And then you could like type in any clarifying questions you have about the context of the problem. That means, what is the scenario talking about? So we have a boulder that's like a rock, like a giant rock, falls off a sheer cliff, smashing into the ground. The boulder's height in feet above the ground at any time t greater than or equal to 0 is modeled by the function h of t equals negative 16t squared plus 124, where t is time in seconds. Okay, so we read the problem. You could go ahead and read this in your mind again, just go over the stuff. Now, in the chat, does anyone have any clarifying questions on the context of this problem? Like, what does this mean, or what does that mean? Like, first off, any questions about the scenario of this problem? Let's put it into the chat. Remember, keep it on task, keep it on task. If you want your participation, make sure that put into the chat if you have any clarifying questions about the context of this problem. That means the scenario of what's happening. Let me share with you all that when I first read this problem, I was like, what does shear mean? What does it mean to fall off a sheer cliff? So I went ahead and looked up the word shear. And when I looked it up on Google, it said that it was like a cliff that's almost perpendicular, so that the rock is falling kind of almost straight down. Okay, good. I'm seeing some questions there. So Nayeli says, what is t greater than 0? Regal says, the t greater than 0 is positive, but it's falling off a cliff. Okay, so we got some questions. Is this the answer? T equals 2.7838 second. I don't know, Stephen. We're going to find out. Are we going to use the function to find instantaneous rate of change? How high up is the cliff? Oh, that's an awesome question, Bruno. Raven said, are we plugging in numbers to get the seconds? Those are really, really great. Okay. What is the answer, Miss Donna? We're going to investigate that, David. How big is the cliff? Seuss is saying t equals t.7838 seconds. All right, cool. So great. You guys have a bunch of questions, but let me bring us back now. Okay, great. We have a lot of good questions out there. We're going to investigate this together. Step 2. I want you all to go ahead and to type out what important information do you think this problem is giving us. Some of you already said it. Some of you were saying about the t greater than or equal to 0 part. If the question was about what does that mean, the t greater than or equal to 0 means time is positive, right? Because time can't be negative. All right, so Juan mentioned the t greater than 0. Great. Angel, you think an important quantity is the plus 124. All right. Darian is saying the cliff is 124 feet. Look at that connection. All right, any other important information we should know that this problem is giving us? Feel free to type it into the chat. Good, Kennedy's pointing out that t greater than or equal to 0 part. All right. Next question I have for you. Okay, think back when y'all were looking at your big ideas packet and y'all made comments on your work. And if you didn't yet, you want to make sure you do that first. But what are possible questions that this problem can ask? You could type it out in the chat. David, so you can write this down or you don't have to. Right now, it's just active participation. If it helps you to write this down, you can. I will be uploading a recording of this later, though. So you could always review this at your leisure. And I'm gonna try my best to kind of take all the stuff y'all are saying into the chat and put it into the next slide so we can have some evidence of what y'all are thinking about. So in the chat, think about our big ideas that we've been discussing. Okay, Angel put a question in. He said, how long does it take for the for the boulder to fall off the cliff? Yeah, that might be a possible question. It could ask, what's the height at a certain time? That's true. Like, what is the height of the boulder at, like, I don't know, t equals 4 seconds? That's a good question. What are all other possible questions that this problem could be asking? Think about our big ideas and what we've been learning. Edgar says, what's the height at t equals 2 seconds? That could be a possible question. What's the velocity of the boulder at a given height? I love that question, Angel. Velocity is connected to average rate of change, which we've been talking about. So I really love that question. Keep them coming. Let's see what other kinds of questions I could ask. Good, Tanya was about to ask that. Is the equation set for t equals 0? Will it change if we change t? So is the equation set for t equals 0, or will it change if we change t? Now, I'm going to try my best to understand that question. So basically, t could be anything as long as it's greater than or equal to 0. That means t could be 1, t could be 0.5, t could be 1.33. T could be any of those numbers as long as it's greater than or equal to 0. I hope that answers your question, James. Okay. Let me know if anyone else wants to get some participation in there. All right, let's jump in. So we have a lot of juicy questions y'all came up with. Here's the actual question I'll be asking for the assignment today. Some of you kind of already knew it. First question is, how long does it take for the boulder to hit the ground? Explain and make connections to a model. So this is the question. First, read it. Let's soak it in. So brainstorm. First off, before answering, so I know Jesus, you're like putting 38 seconds because that's your lucky number. Okay, before answering though, brainstorm. What information from this problem do we need in order to answer this question first? So in the chat to participate, you want to put what kind of information do I need to figure out when the boulder will hit the ground first off? What do I need if I look back at the problem? Ricardo says we need the height of the cliff, the height. We need to know t. You need to know the time. That's true. Also, the height. Time. Perfect. We need to know height and we need to know time. Those are good things. Height and time. Darian says velocity. Tanya says height and time. And then Noelia has a question. What's 124 representing, or 16? Yeah, what do those represent? Great. A lot of you are saying we need time and we need height. Okay, I agree with you all. Weight of the boulder. I really hope physics doesn't come in here because then we're going to have gravity and all that stuff. And I don't want to think about the weight of that boulder, but that might be a consideration, Hakeem. David's thinking that 124 is the height of the cliff. Maybe you're right, David. All right. So how do we figure out all this information? Because some of you are like, what's the height? Isn't the height 124? Let me bring us back to the question. It says, explain and make connections to a model. What does it mean to have a model of something, first off. What does that mean to have a model? Angel says a graph. A graph, a demonstration, a graph. Draw out, Raven says, a diagram. Yes, that, a visual representation. Okay, great. I'm agreeing with everybody. We need a visual representation. What's the most easiest thing we've used, hopefully if you remember in class, to make graphs? Maybe it's something starts with a D and then .com. Yes, Desmos. Juan put it in there. Desmos.com. Why don't we take this function and put it on Desmos.com? We'll be able to figure out maybe the answer to this problem. Let's go to Desmos.com. Oh yeah, what I'm also going to do is I'm going to copy and paste it. Oh my goodness, what's sorry, I'm going to admit Harvey, Shannon. Okay, cool. So I'm going to go ahead and go to Desmos.com. And oh, can I paste the equation into the chat? Can I? Oops, nope. Let me do that. Hold on. The only issue though, Angels, when I paste it into the chat, is that you notice how that 2 isn't, oops, I kind of accidentally sent the meeting. Sorry guys, I put the meeting ID in there. How do I take that out? There we go. Sorry. When I put it into the chat, notice how the -16t, it says t2, it doesn't say t squared. So you're gonna have to fix that when you paste that into Desmos. So let me go ahead and go to Desmos.com. Oh my goodness. Yep. Okay, we're gonna go ahead and paste this. So notice that, and I need to fix this too right here. So what I do is I'm gonna do Shift-6, and that gives me the ability to put that squared. And load up. Are you all able to see my graph right now? Yeah, you wanna go to Desmos, David, unless you wanna sketch this by hand, which is kind of a little bit more work. It's actually easier to have Desmos sketch the graph for you. Let me zoom out. So what I'm doing right now is this is a tall graph, and first off, I see the squared right here. Usually when there's a squared, I know that it's a parabola. So I'm kind of trying to find the vertex of this parabola is what I'm doing right now. Maybe if I could zoom up. And then keep it appropriate in the chat, please. Keep it appropriate. You guys can talk, but keep it appropriate. And when I ask the math questions, just make sure you're participating, okay? All right, so notice how when I zoomed out, I see the parabola now. Great. So I'm hoping we could answer some of the questions that y'all were raising, like what is 124? Is 124 the height, like David said? Is it? What do y'all think? Let's look. Where do we see 124? 0, 124. So that looks like, Abel says, seems like it is. Y'all agree that 124 was the height? So David was like, yup, I'm right. Yes, yes. Awesome. Great. Great, y'all agree. So again, you know how y'all had those questions? It helps when you put your graph into Desmos, and then you could figure it out from there. One thing I want to ask you guys, and this is the next question that I'd like y'all to put this into the chat, is in this graph, what is the y-axis, vertical right here, and what does the x-axis represent? Please type this out into the chat for your participation. So Juan says the y-axis represents time. So you're saying this right here, y-axis up and down represents time. But Noelia says y is height. Oh, Juan corrected yourself. You said it's height. Rigo says time and height is x and y. Okay, I meant height. All right. It looks like we're all in agreement. The t is the time, or x is time, and y is your height. Time and height, and y is height. Awesome. So that's step one, is to figure out what is the x-axis, what is the y. Perfect. So that means it's true. Because if x-axis represents time, that means 0 seconds is t. That means my output represents height, 124 feet. So then that makes David correct. And when he said that 124 was the height. Perfect. The next thing. Okay, great. Now that we've kind of dissected what this graph means, let's go back to the original question so we can answer it now. Okay, it says, how long does it take for the boulder to hit the ground? Now, what I want you guys to do in the chat right now is to tell me, in this graph, where should I be looking at if I want to figure out when in the world that boulder is hitting the ground? So in the chat, it says, James said, do we look for the x-intercept? Angel says the ground, x equals 0, x-axis. At 0, x-intercept, when x is 0. Okay, let me go ahead and listen to what y'all are saying. And then Victoria says, wait, is x time? Can someone answer that? Is x time, y'all? David said, yeah. Great. Oh, okay, look at that. They said, wait, no, we're looking when y equals 0, which is the ground, and Darian also added to that. Yeah. Okay, so let's go where y equals 0, the ground, right? I have two possible points, though. Which one is going to tell me when the boulder hits the ground? Hakeem thinks it's the positive. Okay, Jasmine says it's at 2.78482, the one that's on the positive side. So can y'all tell me why is it the one that's on the positive side then? Why would it not be the negative one? Why can't I say both? Because negative time isn't real. That's perfect. That's true. So I could go ahead and delete this answer, right? Yeah, it can't be negative. Perfect. So y'all, now we've identified when the boulder hits the ground. Can someone write this out in a full sentence? For example, at t equals blah, the boulder hits the ground or whatever. Can someone write that out in a full sentence for us? Like interpret what this coordinate point means if you were to type it out. At t equals c chemica, okay. When t equals 2.784, the boulder has landed. Now t is what? Is it minutes, seconds? What is t? Time, perfect. All right, so Sophia kind of edited David's there. So at t equals 2.84 seconds, the boulder lands. That's correct. And then Regal says when t is 2.784, and then make sure you add in the seconds there, the boulder hits the ground. Perfect. All right, y'all, we kind of did part A together. What you want to do though when you submit your assignment, let me just check our timing. We got 3 minutes, so I'm gonna have to, we won't have time to do part B, right? But I believe you guys have the skills to do part B on your own. This was a very juicy and delicious conversation we had, y'all. So here we go. The assignment is you're gonna go ahead and put what we discussed. It says, how long does it take for the boulder to hit the ground? Go ahead and type in the stuff we discussed, and though, this is what I want. I want you to insert a picture of your work. That means put the screenshot of Desmos in for part A, because I want you to kind of, again, dissect that model of the graph and interpret what all those points meant. Like, what did that high point mean? How did that connect with what David said about 124, like the boulder started there, right? What did the intercepts mean, and why did we get rid of one intercept and keep the other? I want you to tack that out here. And then for part B, here's the second question this assignment is asking, and it's the last question. What is the average rate of change of the boulder's height over its entire fall? Again, if you forgot how to calculate average rate of change, click here for the video support. I didn't have time right now on this live screen to show you all how to do that, but there is video support, and I give you a little bit of feedback on the assignment. Yes, you get credit for this as well, David. You do get credit for being present here. There's going to be a separate credit for the Zoom, and there's going to be credit for this assignment. So that's correct. Yeah, thank you, Bella. All right, we don't have time for that wrap-up question, but the last thing I want to leave you all with is please make sure you turn in the Google assignment. Yes, you will get credit for your participation in the Zoom meeting, and leaving you with this quote: you must tell yourself, no matter how hard it is or how hard it gets, I'm going to make it. Make sure that y'all are present in tomorrow's senior town hall meeting. Make sure that you represent. It's going to start at, I believe, at 11 a.m. Check out with your advisors and how to join. Yeah, Tony is saying some no CSP. Yeah, make sure that you share that. But anyways, y'all, I had some fun. Thank you for participating. I got to go ahead and go into my AP Calculus class. Yep, bye, y'all. Go ahead and log out. I'm going to go ahead and stop sharing.